Good evening all. Last class we have discussed load curve as well as load duration curve. In the second module, the next topic is some definitions. So first of all, we shall see what is connected load. It is defined as the sum of all the loads, either on or off, connected to the power system. That is, all the loads physically connected to the system are called connected load. It can be in the on position or in the off position. All the loads may not be switched on together, but such loads have to be calculated to determine the required power and hence the capacity of the generating units. We know that all the consumers may not switch on all of their loads together at a time, but such loads have to be calculated in order to determine the maximum demand that may occur on the system and the capacity of the generating units. Next topic is the average load. The average load on a station equals area under the daily load curve divided by total hours if it is a daily average load. So, area under the daily load curve gives the kilowatt hour generated on each day. That divided by total number of hours will give you average load. It indicates the average value of all the loads occurring on the station for a given time period. It can be daily, monthly or yearly. So in general, the average load is equal to area in kilowatt hour. If it is daily load curve, it is the area in kilowatt hour under the daily load curve divided by number of hours in a day, that is 24 hours. So this is the expression for average load. Area under the daily load curve divided by 24. Okay. Similarly, we can have monthly average load as well as yearly average load. We are taking monthly average load, number of units in kilowatt hour generated in a month divided by number of hours in a month. That will give you monthly average load. Similarly, yearly average load is the number of units generated in a year divided by 8,760 hours. The total hours in a year. Next term is the maximum demand. It is defined as the maximum value of load that occurs on the system during a specific time period. It is the maximum value of load that occurs on the system during a specific time period. That can be a day, month or year. It is the greatest demand of load on the power station during a given period. It is important to know the value of maximum demand as the installed capacity of the plant is decided on the basis of maximum demand also. So, the installed capacity is being decided by total connected load and maximum demand also plays an important role in deciding the total installed capacity of a power plant. The power station must be capable of supplying the maximum demand. The maximum demand is measured by a maximum demand meter. Maximum demand is generally less than the total connected load because all the consumers do not switch on their connected load to the system at a time. The knowledge of maximum demand is very important as it helps in determining the installed capacity of the station. The station must be capable of meeting the maximum demand at any time. Next term is the demand factor. It is the ratio of maximum demand on the power station to its connected load. So demand factor is equal to maximum demand divided by connected load. Next is average load. Average load we have already seen. The average loads occurring on the power station in a given period, can be day, month or year, is known as average load or average demand. The value of demand factor is usually less than 1. Demand factor we have seen, demand factor is equal to maximum demand divided by connected load. Normally this maximum demand will be always less than the connected load. So that its value, demand factor, will be always less than 1. It is expected because maximum demand on the power station is generally less than the total connected load. If maximum demand on the power station is 80 megawatts and the total connected load is 100 megawatts, the demand factor is equal to 80 divided by 100.8, which is less than 1. The knowledge of demand factor is vital in determining again the capacity of the plant equipment. Next is load factor. It is defined as the ratio of average load to maximum demand in a given time period. So load factor is equal to average load divided by maximum demand. It can be daily, monthly, yearly load factor according to the time period that we are considering for taking the average. It is less than unity because the average load is always less than maximum demand. The value of load factor affects the production cost also. It should be as high as possible. If the load factor is high, maximum demand is low as per the expression for load factor. And required station capacity, which depends on maximum demand, is reduced due to this. This reduces cost of production. Load factor should be as close to 1 as possible. Also, a higher value of load factor reduces the variable loading problems. This is because a higher value of load factor implies less variation in demand at various times. Due to this, the effects of variable loading are minimized. Hence, load factor should be as high as possible. Next term is diversity factor. A power station supplies a variety of consumers. Each consumer will have an individual maximum demand, and such maximum demands may not occur at the same time. We have studied about different types of loads on the power system. Agricultural loads, domestic consumers. Even the domestic consumer varies from 1 to 1. So each consumer will have individual maximum demand, and all these maximum demands may not be occurring at the same time. Diversity factor is defined as the ratio of the sum of the individual maximum demands to the total maximum demand on the system. So the factor gives the idea that how much the consumers are diversified. It can be expressed as diversity factor is equal to sum of individual maximum demands divided by maximum demand of the power station. Obviously, diversity factor is greater than 1. The greater the diversity factor, the lesser is the cost of generation of power. This factor gives us the diversification of the load and is necessary to decide the installation transmission and distribution capacities of the plant. Higher diversity factor means that maximum demand of different consumers occur at different times, and hence interchange and scheduling is easier and operation is optimum. So if the maximum demands of different consumers are occurring at different times, the load on the generating station will be lesser. At the same time, if all the maximum demands are occurring at the same time, it will be a tough time for the generating station. It will be heavily loaded. Another implication of higher diversity factor is that total maximum demand is lower. This reduces the size or capacity of the required units and also the production cost. In order to increase the diversity factor, the following methods have been employed. Scheduling loads with certain time differences known as staggering of timing. Then making use of different time zones for different types of loads. Giving incentives to particular consumers to utilize electricity at off-peak hours. We know that during peak load conditions, the power station, generating station will be experiencing maximum demand on that. So, if the consumers are utilizing their or having maximum demands at different times, the generating station will be it will be good for the generating station. So, giving incentives to particular consumers will encourage them to utilize electricity at off-peak hours. Then use of daylight saving. So, instead of using electricity for lighting purpose, we can make use of the daylight when if it is a peak load condition. And next term is the plant capacity factor. It is defined as the ratio of actual energy produced in a given time period to the total energy that could have been produced in the same time period. So plant capacity factor is equal to actual energy produced, that is in kilowatt hour, divided by maximum possible energy that could have been produced based on installed capacity of the plant. So average demand, it is equal to average demand divided by installed capacity. If we consider time period to be 1 day, the plant capacity factor is equal to total kilowatt hour output of 1 day divided by plant capacity into 24 hours. Next is plant use factor. It is defined as the ratio of actual energy produced in a given time period to the product of plant capacity and the number of hours that the plant was in operation. So plant use factor is equal to actual energy generated in kilowatt hour divided by plant capacity, it will be in megawatts, into time in hours the plant has been in operation. Suppose 100 megawatt plant produces 50 into 10 raised to 6 kilowatt hour energy after being in operation for 2500 hours in a day. Then plant use factor is equal to the actual energy produced, that is 50 into 10 raised to 6 divided by the capacity, installed capacity of the plant is 100 megawatts. Convert that to kilowatt. Then the time for which the plant was in operation for the year. So, by calculation, we will get plant use factor is equal to 0.2 or 20% of its capacity. So, that's all regarding various factors that we have to consider for the power system operation. The next class, we shall continue with the second module with new topics. So, thank you for listening.